Pity you can't put
you know, like
oh, hold on, what's my doing? I'll log into Twitch and it starts playing noise.
Let's see. Yeah,
We're here.
we're live. Yay. Okay. So today it's me, Walter, and Paul. And we're going to try to create a tactic in Lean that can prove a lot of things about lists. And we've done that before in Coq. Here is a tactic called list empty. It can prove a lot of things about theorems for empty lists. So if you have, say, in your hypothesis, something that says an empty list is equal to a list that is not empty, then, well, then your hypothesis is wrong, and we can just call discriminate and it will be proved. And there's a lot of kind of obvious cases where you don't remember the theorem, but you know that this is true and you don't really want to think about it because it's just lists. You have more important things to worry about.
More important things to do with your life. Yeah.
Yes, then worry about theorems with lists. But lists are important if you worry about strings, and strings are important if you worry about regular expressions, which we kind of care about. So that's why we're creating this tactic. We have started some work before in Lean, and we created this tactic called ballistic. So see our little pun there with list, ballistic. And this ballistic tactic, we've built a helper library for it as well, which we call Ltac, because we can't find something similar in Lean yet. Hopefully someone else will build a better version of this. But until then, we've got our version of Ltac, which can give us a list of the hypotheses with their names and the properties. And there's examples in this file about how to use all of these things. It can give us the goal, and we can apply tactics, and we can use the quote for library to match patterns, match properties in our hypotheses. Here's one where we match it in our hypotheses, and here's one where we match it in our goal. So there's lots of examples in this file that you can look up in the KTDIT repo under std Ltac. And we're just going to use this library to extend this ballistic tactic to basically cover everything we did before in our Listerine tactic in Coq, so that we have something similar. Okay, so first thing is, did I cover everything, Paul?
I think so. Yeah.
Okay.
So what's currently implemented is some empty ones, right?
Yes. So first thing, I think, yeah, we should split this out into the calling something that is just empty, and so that we just get some separation of concerns here, because the tactic is going to get quite large. So how, well, I guess we could just rename this for now to list empty.
Yeah.
What do we call this here? Yeah, so this is just going to be local. We're not gonna, it doesn't have to have a good name. I think we can we, is the word local, or, yeah, right. Then we can just replace these, and yeah, so that's good.
Okay.
Okay, so ballistic is a tactic that tries to solve simple theorems with lists. List empty is a tactic that tries to solve simple theorems about empty lists.
Mm-hmm.
And then we have our reference here. Yeah, so this looks better already. And later we can figure out how to combine it all into one tactic, just like we did in Coq. Where did we do that? Listerine. Yeah, over here, where we have a tactic that's just an OR of a bunch of tactics, and then our big one is just a repetition. So just apply this tactic over and over and over. But for now, we need to start with our smallest building block, and that is this list empty tactic. Let's see what we've done so far and what we still have to do. All right.
If you go to the lean tactic,
Yeah.
there's one bit I've forgotten, which is, yeah, on line 32.
Mm-hmm.
So you just have, you made some hypotheses on line 32, and then nothing runs.
Oh, yeah.
So you don't need to run any. Do you need to run anything at that point, or is some magic happening?
Oh, yeah.
Or maybe you just want to introduce hypotheses, but we want to.
Yes.
Because it's just okay. We just introduced left and right. Okay, fine. Yeah.
Yes.
Not actually solving the thing.
Yeah. It's just a small step to take us forward. Sometimes this tactic doesn't solve the goal. It just makes it easier to solve.
Mm-hmm.
Once you have something is equal to something, you can do a rewrite, and that's usually very useful. So actually what would be better after this is to go do a rewrite in all tactics for this empty list. So maybe let's just add a to do here. Rewrite.
I really find the suggestions it comes up with quite funny. That's one of the problems I have with the Copilot.
Yeah.
I find some of the suggestions just too funny, too amusing. It's like distracting. It said to do this doesn't work. That was its suggestion.
Oh, really?
Yeah.
Oh, I missed that. Oh,
yeah.
Now it's too clever.
It's like,
my bad. I missed it. Okay, that's a good one. Also, I think I just want to copy something from the example here that I changed. Whoa. Yeah, here we are. Okay, so one thing we can do instead of using these if lets is we can just do a match.
That's better.
And then we just look again that I have the syntax right. Yeah, something like this. So we can copy this here. Yeah. But it doesn't work because non-exhaustive match. Okay. So yeah, you just have to return it.
Yeah, do nothing. Okay.
Yeah. All right. Cool. Everything's still
Great.
working. Yeah. It just looks a little neater.
Yeah.
Yeah. I think we can even do that here as well. Yeah. Again, non-exhaustive match. Yeah, if we don't find anything, we don't care. All right. Cool. That already looks better.
Mm-hmm.
All right. So first thing we want is, I think, to make some examples of these cases where a discriminate would work, and then maybe we have the discriminate tactic that we can just always run as part of this, but let's see. I'm going to copy these. The syntax is almost the same in Lean, so this shouldn't take too long. Example, then yeah, example implies false, and maybe we want to say this is some hypothesis, and we want to prove false. And then, oh, almost. And then we want to say list empty, and it should be proven. Yeah, these two are kind of the same as these, so I think. Oh yeah, it was just for the syntax versus the non-syntax version. Like if you wrote out cons versus,
you could
just to put two colons.
there's cons function.
Yes. So I wonder, is there a cons function? There should be. List.com.
Yeah, okay. List cons.
Okay, so what's your problem?
It doesn't understand how to synthesize implicit arguments.
Okay. There is some alpha. Okay, maybe one more. Okay, maybe let's add an alpha.
Function perspective.
Oh, I can't put patterns here. Sorry.
Oh.
Yeah, that was stupid. Okay, yeah, there we go. So this is just, did I write it out or did I use the syntax? Either way, list empty should solve it.
Unknown identifier. So you need to say by, I think.
Oh yeah.
So go into tactics mode.
Yeah. Well, I had said by, but okay. Oh, it already works. Okay.
Oh, we should have one for the left and right destructor as well, I suppose. Do we have one?
This is the left and right, or did you mean something? Oh, sorry. This is
well, it's the concat. It's splitting the concat into the disjunction or the conjunction. Sorry, the last line 31. Do we have an example of this?
Oh yeah, we don't have this yet. Let's just check. I just want to understand why this is already working.
That's a good question. Okay.
So
List
in our
cons?
hypothesis, here we go. Here we've added it. Okay.
Yeah.
And actually we already had an example. So.
Oh, right.
Yeah, I'm going to just delete that. Okay, so we've done this. I wonder if we've done that one. This looks like this. But yeah, I don't think we've completely done that. Because we're not handling the not equality. Well, I guess this is just what we want to prove. And I don't think we need to. Oh, we can add this. Oh, but it works.
Yeah, because isn't not equality defined in terms of equality or something like that?
Yeah.
So,
But it does figure it out. So
okay.
I'll take it.
Mm.
That's pretty great. Okay. And then this is the one we were just talking about. Oh, an interesting here. In this case, we are rewriting with it.
Ah, okay.
Yeah. So we actually do need to complete our to-do. Okay, so we've created the variables h left and h right. And now we want to rewrite that with that in everything. So we need to come up with an example where we could prove something after the rewrite. So we had h. What is the hypothesis after h? H. Usually you start counting up letters, but I've never used I as an hypothesis.
No, I seems not good.
H is 0.
H prime.
Okay.
Yeah.
Let's go
H
0. And we can make this h0 just, and then h1.
Mm-hmm.
So we want the y's in here that says it equals z's, say. And then want to prove that z's equals the empty list.
Mm-hmm.
Right? So now, yeah, here if we rewrote y equals 0, empty listing, it would have gotten here, right?
Yeah.
And then maybe assumption would work. I don't know if this symmetry is included in assumption or not, but I think
We'll see.
yeah, maybe
Well, you can do it the cheap way. Yeah.
Yeah, let's make it easy.
Let's do it that way first.
Yeah. Okay. So now we want to rewrite. Yeah, I think we have a try tactic. And there's a try RW. Oh, we can actually do both, right? In star, does this work? At star, how about that? Okay.
Yeah, so on line 36, it should be H right rather than right.
On line 36. Oh, we don't have
right.
We don't have the actual names.
So why does that work then?
It doesn't work.
Oh, because it's just in quotation. Okay. Yes. Yeah. The quotation, it doesn't do any scoping.
Yeah.
Because you got to quote it. Yes. Okay.
Somehow that didn't quote correctly. Let me see.
Oh.
I think
is it no? It's is it tilde instead because it's inside a?
Yeah,
it's a quote. Oh, dollar.
Yeah, dollar. Let's see, dollar. Okay.
Okay.
Yeah. There's a thing for this. Let's see. Pretty sure I've done this in
Is it colon term?
these examples.
Is that?
Oh, yeah, where did you see that? Here. Ah, there we go.
Yeah.
Hmm.
Colon.
Yeah, so
This comes from the quote library.
yeah, I think this is like a cast.
Okay.
Okay, but no. Oh, it finished.
No goals to be solved.
Yeah.
Ah, okay, fine.
Yeah, but RW,
that's fine. Took me a while to
I
see
think
what was going on
RW
there.
is
Yeah.
too smart. Yeah. Yeah, see, RW was too smart here and here. Yeah, yeah. No? Ooh. Yeah, now rewrite is way too stupid, but RW was too smart again. Hmm. No, it was also stupid. Okay. So here it rewrote in itself. Because
Yeah, that's never a good thing, is it?
no. So what if we do rewrite? If we do it more sequentially. Okay, what if we just do one? I just want to see what happens. Yeah, already. Why would you? Oh,
It's the @ star, I guess, includes the current hypothesis,
yeah.
maybe,
No.
which is never what you want, right?
Yes.
It's sometimes what you want, I suppose, but
No, you also lose the thing.
yeah.
Yeah. So now I wonder if there is other tactics for rewrite, like subs. Here we go. Substitute each x with e in the goal.
Subst vars.
Okay. Only in the goal?
Yeah, so that's the default behavior of rewrite, I think. Only affects the goal. Unless you specify
Yeah, but here also, but subst vars, I think that's what we want.
Yeah, all hypotheses.
Okay, let's see. We've broken it up and we just want to run subst vars. I mean, yes. Yeah, well, technically, right? This once you've split it up, it's really pointless to keep this hypothesis around.
Yeah, that's true.
So, and that's this one. And then, oh yeah, and then it becomes this and thing that which you yeah, which we're splitting up as well. So that also becomes pointless to have around. So we could kind of go and remove the original hypothesis and the hype name after we've split it up to clean up the hypotheses. And then these two aren't there.
Mm-hmm.
And this is a very reasonable place to be.
Yeah, yeah.
And here, kind of, yeah, the same thing. Because once you've substituted the variable, there's no reason to keep it around anymore.
Yeah.
Yeah. Okay. How do we, is it remove? Delete? Destroy.
How many synonyms?
Clear.
Oh,
Okay. So, okay, we don't need to know what these are anymore. The subsvar is going to do exactly what we want. After we've done this, we can run clear. What is this? Cases with. Does this do a thing? Let me just. Oh no, I don't know how to do that. No, okay, just clear.
mm-hmm.
Dollar name. So this, okay, name and hype name is very confusing. So let's say conjunction name.
Mm-hmm.
And then we can also clear conjunction name and then do subsvars and then riffle.
Yeah. Nice.
Yeah.
So what to do?
Yeah, that's good. Okay. I like it. Okay, so yeah, there's probably a better way to do this, but it's good enough for now. Okay, we've done that one. Now it's just if it's the other way around.
Mm-hmm.
So we want to do this, but it's almost the same. So now, oh yeah, so we need to do symmetry in that symmetry at name. But we don't have symmetry.
Unknown
Okay.
tactic. What's it called? No, there's no there's no syntactic. It must be called something else.
I feel like we've run into this before.
Yeah. Maybe it's not a tactic, it's a
I think maybe even we made a comment. Yeah, here we go. Thank you.
So it's a little function.
We have it. Oh, but you can't apply it at. Okay, so we have to create a new late symmetric name. So we say EQ sum name. Then this becomes sum name. Yeah, that does it. And yeah, we can also delete sum name.
Mhm.
Yeah. Cool. It's a bit. I wonder if I'm ready to. No, I don't know enough about syntax yet, how to create new syntax, but almost ready to create a symmetry tactic.
Yeah.
I just don't know enough yet. Okay. So here we have a few things that it looks through the hypotheses and the goal. It just tries to find this pattern where we're trying to append the empty list to something, and then it just rewrites based on that, just to get rid of the empty list, and on the left and the right side. So we don't have this context operator in Lean, which basically just goes through. It tries to find this expression deeply nested within your expressions. So we don't have this operator, but it doesn't matter because rewrite
Just
kind
try.
of does that. So we can just use try, which just tries to rewrite. And if it doesn't succeed, then it wasn't there. So we can get away without having this operator. So we just need to create some examples. We have this one and the other way. H. One of them is it's in the hypotheses. So we might. Okay, one of them is just the goal. This is just the goal. And the others are their hypotheses. So I think for that, we can make it wise.
Mm-hmm.
And just try to prove that wise is equal to the empty list. Like this. I guess. Okay. And all of these should just work. And currently they don't. But that's why we're going to fix it.
It's about, yeah, I always get confused. So the error appears under the by because the tactic's not complete, is it?
Well, unsolved goals.
Unsolved goals, yes.
Yeah, so there's nothing wrong with any of the tactics being applied.
Yeah, but it's the outer thing that's wrong.
Yes. So I think we can do these tries inside the default.
Yeah.
Actually, just 1 second here. just let me understand if I understand what like imperative programming. We assign the goal, we try a match. If it doesn't work, we return. But then we still go on to the next bit.
Yeah, so isn't this like just because we're just binding goal? So when we say return void, return, does that bind goal?
Yeah, but yeah,
to
but
void?
I think it's like this actually.
Oh,
You see, like
okay.
it's let this, then
Yeah.
do this. But here we're returning.
Yeah, but isn't that like a monadic return? So
Yeah, but we're in this do block, as far as I understand.
yeah, so so it's just like in Haskell when you have something returning void.
Yeah.
You have so it will go on to the
Oh yes,
That's right.
yes. Yeah, yeah.
So it's just not, we don't have to bind it because it's void.
Yeah.
We don't have to bind it in the do block. So
Yeah, because it's actually,
it's like that, but you don't have to do it because it's void.
yeah. Okay. Yeah, this is actually what's happening, but yeah, okay.
Yeah.
Okay. Cool. Thanks. I'm back.
It looks weird when
Yes.
if you try thinking, yeah. The return. Why did they pick return?
Yes.
whoever the monad gods were, they picked a bad name.
Okay, but if I actually want, so okay, currently it's going to execute one thing on the goal and one thing on a hypothesis. Well, actually no, it's going to execute one thing per goal and one thing per hypothesis, which is slightly, it's different than this logic, which executes the first thing and then you can repeat if you want. So it feels a bit more harder to control. So maybe there's a better way, or we don't care. I don't know. But because otherwise we can just go, okay, after you tried things on the hypotheses, let's just run some tactics. So maybe let's do that.
We could do that. Yeah.
And then, but I think it would be nice to control it more later. So now we can just say try rewrite with, and we have all these list tactics. And we want, they should be almost the same names here. Yeah, list app null. And list app null R. And we just do that at star. And same with write. And somehow that doesn't work.
No goals to be solved. Oh, that's because don't we need to try?
Oh, yes.
Yeah.
But also oh no, there, that's it. Nice.
But then.
And then
Also
what happened?
Goals.
Oh,
we lost something.
No, that's just want to prove it.
Okay.
So that should just,
we need egg. Then whatever it was.
Yeah, like, you can rewrite this, but mm, yeah, there are some cases where this simplifies to a small equality. So I guess we also want to try subvars as well. Can we do that? Does that make sense? Yeah, and then we can just do rifle. Yeah. Oh, this tactic is too powerful. Oh. Like, yeah, subvars is not like, I wonder if we can specify what we want to subvar. No.
Where does that come from?
Well, there has to be some definition here.
Yeah. Well, maybe this is one that's like magical C++ implementation. It's, well, GitHub has this symbols, no symbols. What? You get symbols, I don't. My GitHub says symbols not available for this file. I'm in the same file as you.
Yeah, look at this. Yeah.
Substvars.
Yeah, so here's the definition.
Local decal. So we have this local context. So is that line 216? So we want to pass in this list of local decals, I guess.
Where?
On line 216?
To
16.
Oh, this, yeah. This goes through the context.
And substitutes
the mvar for okay, wait, first checks observing. Oh, wow. Where is observing? No other references. Look at that. Oh.
monad backtrack.
Where did you see backtrack? Oh, there. Oh, there. Nice.
Seems to be where it was defined.
Yeah.
Try. Oh, so it's say some state monad thing.
Yeah, so it's just
So
it's
just
trying
puts you
something
back.
fails,
Yeah.
it just takes it back. Okay. So we were these are all exported so we can access them. Lean meta, I think so.
So subst core substitutes. Oh.
No.
Oh, it's yeah.
How does it get to subst core? Subsum var. Subst.
So this
Subst-
subs is basically just
Calls.
try
Calling
subs.
subs.
Like,
Yeah.
I can't remember what the F var ID is. Is that the hypothesis name ish?
Hmm.
Okay, but okay, this is maybe going too deep for today. Like, let's go play some more with the lists and just build up our test case library. I mean, but yeah, there's a lot to figure out there.
Mm-hmm.
Okay, so here we have some more examples. So I think we can copy some more of these. This looks familiar, but I don't know if we actually have it. We have things close to it, but so we just want to prove this. And list empty should do it. It doesn't. Good. Good taste. Yeah, because I think it's kind of expecting this. And what we've done here is not thorough enough. It's looking at the hypotheses, but yeah.
Yeah.
So we need if it's the empty list and const with something. We need can that just work? Just want to check. Is it the other way around? No, it's the right way. Okay, no.
Saying
Cool.
unknown identifier. Oh, it worked. It was just slow, was it?
No, it's still not working. Yeah. So let's just see how would we solve it ourselves, because I think that doesn't work. Oh, unknown identifier. Okay, that.
Yeah.
Okay, so
Oh,
contradict.
list cons, not no. So list app.
Oh. Do we have it? Yes.
List cons nil any. Okay.
Yeah. Yeah. Okay. So that's what we want.
Mm-hmm. You've just got two applies on that call. You pasted it in.
Oh.
Yeah.
Nice. Here we go. Okay. Cool. And then the other way around. This one. Yeah, we have it here.
Nice.
Nice, cool. Okay, what other test cases? Oh yeah, just a singleton list.
Mm-hmm.
Oh, I copied the name. That's useless. Maybe we go to the bottom now. Just okay, that worked.
Oh yeah, yeah.
I don't know why. And why not the other way around? Cool. Yeah, I think we have this. And this. And this. Oh, I think we just added that.
We just started that one, yeah.
Yeah,
And
and
the
this
following
one.
one.
This one looks familiar. Let's just double check. Here. I'm just gonna move these to the bottom since they're slightly more complicated.
Yeah.
Yeah. This is the same. Yeah, and I think we have this one and this one. So I think we're done. We're on to singleton lists. Well, that's a good start. I'm just gonna copy this. Well, I'm gonna copy all of it.
Mm-hmm.
List single. What is 2 element is unreachable? Okay. Whatever. Okay. Okay, let's see. Our first one. Oh, yeah. So if we are appending two things and they're equal to a singleton list, then either the first one is empty and the next one is the singleton, or the other one is empty.
Mm-hmm.
Yeah, and you only have to worry about these two cases. And so let's see. Maybe this is a theorem we want to prove, and then rather apply that theorem than have it all in here.
Yeah. Yeah, I think it's a good idea.
Or-
That's a good, probably good principle.
Yeah, or this is a thing already. Let's.
Yay.
Yeah. Okay, it is. Okay, so this is. Okay, it is extra work on top of that to then. Oh, okay. Okay, yeah. What we did here is
Struct
like destruct the newly created theorem, which is this.
Yeah.
Which means we go down both paths. In like we create two proof trees, and then we destruct the ands and do a substitution, because then only we can substitute.
Yeah, Yeah, that looks really odd, doesn't it? Because you name both branches the same thing,
Yes.
and then it's because you chain together. It means you can do the chain. Yeah.
Yeah. But the reason is when you get to empty lists and singleton lists there, and you can do substitutions, there's a good chance you might be at the end of the proof.
Mm.
And if you repeat this tactic again, you might just solve the goal, I guess. But I think as a start, we can apply it. Let's see our examples here for this. So yeah, this is it. Okay. That's not a good example. Oh, that was it. Okay. Okay, let's for now just go with applying it, and then if we get frustrated proving things about lists, then we can come back. Because it will be quite obvious, because we'll see this hypothesis that it's this large thing.
Mm-hmm.
And then we'll be like, oh, it would be great to just break that up. And then, Okay, so we're going to match the goal, the symmetric goal, if there's an hypothesis with this, if there is an hypothesis, oh no, this is different. Okay. Okay, oh, we're just matching if there's an hypothesis or the symmetric hypothesis. Okay. And we want this. Maybe a Z? No. The highlighting stays the same. Sorry. Now we need to create a new hypothesis with this. Where is... Here we go. That's a better example of what I want. And sorry, the theorem name.
Yeah.
And it's not implies both ways, so we don't need.
Oh yeah, I forgot what MP stands for.
Yeah. Okay, but we need an example. And I guess our example can just be this for now, the actual proof.
Mm-hmm. Well, it should work with that, so
Yes.
at the very least.
Okay.
Yeah, so there's a typo on 116, 116, the name, yeah.
Okay, fine. Oh, obviously. Our pattern match isn't up to scratch.
Right.
Able. What? Oh, what?
Oh, app eq units application type mismatched. Oh, we need to give it an underscore or something?
Yeah, probably. Let's see. Apply. Oh, no, just. Yes, here we go.
Nope. Some more underscores.
Yes, 3 underscores. Let's see.
We get one for the.
When you're going to apply this, I do think all of these are implicit. So I think we can get away with.
Okay.
And what theorem does that break? Come on, there. I saw a red squiggle.
There it is.
So-
But where is it? I can't see it. Ah, it's on line. Yeah,
There we go.
there we are. 204.
Nice. Okay.
Oh,
Okay. I think we need to build. That's fine. Then probably restart the server. Yeah, there we go. No, client's not running yet. Okay, fine, fine. Hey,
back.
how does it? That did the work.
Lovely.
Now we can say this. And we can probably also clear the original. Yeah, so some things are interesting here. Like I want to say hsim, right, is actually not hsim, but whatever this name is, symmetric. Yeah, and in the end, by the way, I just have h left and h right, so this actually doesn't matter. I'm gonna delete them, but I want it to be whatever h was, this name was.
Yes. Yes.
I wonder, can I
Name dot something. Oh,
hey, oh,
dot
can I-
raw. Or colon raw or something. No.
okay, wait, what is this error? It's just
Yeah.
okay, what's wrong? Like,
Fail to synthesize instance. So it's appending something of type question mark M blah
Yeah.
blah blah to a string. That's
this
an
is being
ident.
ident.
And then you can you get a string out of that?
Yeah.
Not clickable.
No. That's also kind of important thing.
Yeah.
Okay, how do I lean? Is it, how do we say type? Oh, this is bad. This is not a good one to search.
No, everything is called ident.
Yes. Okay. Let's see. Source. Lean. Good. Oh man, this is too many things. Oh. Why aren't you not clickable? Why aren't you clickable? There we go.
Oh, found it. Okay.
Yeah. T syntax. .raw. It will give me
Yeah,
syntax.
let me try that.
And then
raw val
atom node.
raw val.
I don't think it's val, but I mean,
Well, there's raw val was a property. Raw val. That's it. Raw val, I think. No.
wait, where did you see that? Here's a raw.
So raw, and then in syntax, go to syntax, and it had a whole pile of stuff, including raw val, the literal substring.
Oh, but that's here.
Oh, okay.
Yeah.
How do you? So you pattern match on it then, unless it's got a
No,
projection function.
there has to be a toString or something. Is there a derive? No.
There's get kind, get arg, get args, get
ID. You know what? Oh, maybe Ltac is too smart. Because it goes make ident from a name. A name is a lean name. When we were here, what is it? Name. We're so close. Where's the
yeah.
here? Lean dot name. Hmm. Oh. Oh no, where did it go? Where did it go? Come back. Oh.
We need a what? Do we need a name or a string? What?
But usually the name will be an actual name, a string. So a string name,
Okay.
is what? Dot string. So you should be able to do a toString on this. Where's make ident? Like, because we call make ident in our Ltac.
Oh, we do. What is
Yeah.
that?
It takes a name.
Oh, but it needs to give like, oh, two-string val. The name has a two-string.
Yeah. Yeah, there we go. There we go.
We just can't see it anywhere,
Yes.
but it has one.
So if this was toString and this was string, what happens? This doesn't work anymore. Okay, but this is fresh. Fresh is fine. It's when we say get hypotheses here.
Gives us back idents.
This is also a name. So this, if this was toString, what is, oh, wait. Just before we go too far here.
Mm-hmm.
In this case, can we do toString? I wonder.
Yeah.
Hey!
We should have just tried that.
Yeah,
We couldn't see whether instances were defined.
yeah. So I don't blame us. We'll never see it, will we?
No, it's get deleted.
Yeah. Okay, I'll take it. I'm gonna take it. I just want to do the same thing over here. Well, it would be kind of interesting to say, okay, make a hypothesis. You're gonna, yeah, pass in the original name, your suffix. No, it's weird. Right?
But before, was it? Is it doing anything to like deduplicate? What if there's already a hypothesis with that name?
Yeah, it's doing that. It will.
Oh, okay, right.
Add another.
Add an underscore one or something.
Yes.
Okay.
Yeah, that part we actually fixed last time. So.
Yeah, I remember now. We saw it. I've seen an underscore, H underscore one, etc.
Not dollar. Sorry. Yeah, I think this is better. Okay. We also wanted to do that here. That's was the point.
Right. Then do we want to clear it?
Yeah, so this will be a new name. And then it would be nice to rename it after, so we
clear to name. Yeah,
to override it.
Oh, there is. I think there is a tactic for that.
Cool.
I can't see. Can't see it. Well,
Rename I is the best I have, but
no.
not exactly what I want. I have
Well, because once we've deleted it, we can always create it and then delete the other one. I don't know. I can't see any like technical rename.
So you can go make hype. String name. Let's just new name.
Then clear your new name. Oh. We can clear new name.
Yeah, but this is, so instead of make hypothesis, we can call this like override or replace hypothesis. And then we can make a function for this. Does it work, by the way? No, absolutely it doesn't work. Okay, let's see what this did first. Okay, so our first mistake is toString doesn't work.
Oh, sorry. By the way, there is a tactical change. So change.
Yeah. Change.
Yeah. Oh no, I don't think it. No, it doesn't work because we'll change goal from target. Yeah, ignore. Sorry.
Almost.
Right.
Okay, but our toString is the problem. It's not doing what we think it is.
Not surprised.
No.
We can't actually see the instance, so
Yeah. So I wonder if I don't call make ident here, then we get a lean name. Can we do that? No. Is it dot make ident? Oh, I already forgot.
no, it shouldn't be. Should it?
What was it? Oh, it was lean dot make.
Lean dot make. Yeah.
Yeah, see, this doesn't work well. That's why I added it. Yeah, because otherwise you have to go, okay, actually late name. And then name. That's just kind of lame.
That's weird.
Yeah. Yeah, so it's gonna take too much work to test if it would be better without being an identifier.
Yeah.
Okay. Okay, so we still don't know how. Yeah. So, sorry. Lean dot ident. Okay. And lean like ident. It's with this. Now we can command click here. Convert a string into a substring. What? Okay.
Just makes it more efficient to slice. I don't know.
Yeah, but it's not. Okay, fine. Rub.
Brilliant.
Okay, that's a problem for another day, I think.
Yeah.
So now let me just try to go back.
But what was the problem with toString name? Because I wasn't paying attention. Oh, it put.
Yeah.
Oh. Okay. Interesting.
Yes.
So that is it because that source it like prints the source position out with it as well,
Yeah.
and in our case the source position is empty or nothing.
Yeah.
Okay.
I think so.
Mm.
Yeah. Actually, I don't think I can continue without this.
But we can always pattern match the ident. We can just write a projection function for the what was it, the raw val?
Yeah. Yeah. It's
So ident syntax, and then
raw.
this thing called raw val, which is the literal substring from the input file.
It is just so much more than we need. Like,
Okay.
we know it's a string. Like, we know it's just.
Yeah. It's just there's no projection function for the ident constructor.
Oh yeah, we know it's an ident. Okay.
Yeah, we know it's an ident, so we can just project.
Okay. Let's just see if we can write it.
I don't know if there's did the constructors get projection functions for free? I don't know.
I don't know. I was thinking
Well,
of
we
just
tried
doing
it, I
this.
suppose. Yeah.
What do you think?
No, this makes sense, yeah. So we should match it with.
Yeah, this is kind of what I wanted.
Yeah, but it's lean dot. What? Okay.
Is it? What?
No, ident has a string, does it?
Dot raw.
Yeah, dot raw, and then we want to pattern match on ident, if we can. Syntax, and then the constructor is ident
Yeah. And there's
with some more arguments.
info, we don't care. Raw val, maybe.
It's the thing we want, I think. We'll see whether it is.
Val is also good.
Yeah.
I think
The past identifier with hygiene.
Oh,
And this raw val is a literal substring from the input file.
okay. Okay, so 4 parameters. And let's start with the substring.
Mm-hmm. So of course, how do we refer to this? Syntax. It's syntax rather than ident. Because the isn't it syntax rather than ident? Because ID was ident, and then with ID.raw is a type syntax,
yeah.
and then
Yes. Okay, so what did that do? Oh, we have to call. We have to call the
we
function.
need to call it, yeah, and then it doesn't work. We're calling it on what? That's a name, is it?
Yeah, but the name is an ident.
Oh, fine.
But
And then Toostra says, I don't care.
It's a string.
Takes a string. This says
Oh,
unknown
wait.
identifier. Okay.
Hey. I think that works. Oh no. Okay.
What?
No.
Oh yeah, we've got to give it a chance. Give it a chance.
We clear the old one. We create
Oh,
a name.
but it hasn't noticed that the old one's gone away, maybe. So it's still deduplicating it.
Yeah.
Is that because we're inside of some context which hasn't updated? I don't know.
Yes. Fix that.
Okay.
With here.
With main context. Okay. So we have to do the. Okay.
Hey,
Yay.
well, I don't know what happened now.
Oh, we've got H. We have an.
Oh, yes. We don't need that. Oh no.
Huh? What?
Let's try it.
Hold on. We have to put it in. Don't we have to move that around where we've actually delete the cleared it or something?
No, we're not that lucky.
So it's more tightly. So we have to run.
I wonder what happens. Let's just try something. Have H2 true. Yeah, then it throws it away.
Yes.
But I've specifically made make hype so that it doesn't override it. It gets a fresh name. But if we just go with suggestion, Ah,
Because it has to be a name.
yes.
Yeah.
Ah, come on. Think. Ah, can't remember. Hmm. Oh, suggestion is already a name here. String is a name? No.
Maybe it is string, like in Haskell. Maybe it's like that as like the is string thing. Because name has a string constructor, doesn't it? So maybe it has a.
Yeah, so I do this and just say, yeah, like that. Then when we get here, it no, we don't need to clear it. Oh, no, it didn't override it. Oh, wait. Don't I need to rebuild? Like, felt like it didn't, but yeah, there we go.
Okay.
So what I think is make hypothesis should stay the same,
Yeah.
but we can make a new one. That does what we just wrote. Just replace, or maybe there's a better name.
Yeah, because you could use it would replace if it exists. So what's the
Yes. Oh, does it? I just want to double check that. Yeah, because we still have this old one hanging around. Yeah, it's not really replace. Oh, wow. Yeah, we're not really done here. Like, it shadowed it.
Yes.
So I wonder if we say rename I to H. Does that work? Yeah. Fresh. Maybe term. No. Yeah, what's the problem?
Binder ident. It wants a binder ident.
Okay.
Which I don't know what that is.
No, me neither. Rename I.
Binder ident.
Oh, so close.
Oh, binder ident is an ident or a whole. Maybe we're not far off.
Okay.
Where do we get the... We should just be able to, don't know. If you
Maybe we can go.
lean.ident, don't know.
Okay. Okay.
No,
No.
yeah, I'm not sure how to construct one of these binder idents. Binder ident matches. Oh, sorry, that is the parser. It matches an ident or a whole, but I don't know how you
Okay, but we did give it an
make
ident.
one. Yeah, exactly. Yes, I don't know. Yeah, I don't know what this type means. Like when it says binder ident, this is not a type.
Yeah. Yeah.
It's a something.
Yes. I
It's
remember
a
reading
something.
about it in the book, but I can't remember what. So that's we can go to the book.
Maybe those things refer to like the stuff in the parser, like where it's these lowercase things. So it's saying like the macro, but then how do you pass it something? So you need to pass it something that can be passed as a binder ident. So then I don't.
Yeah, I think so. Also, this is how you would use
So
it
then why is it confused?
in real life.
Yeah. So this a name. Yeah,
Yeah, it's a lean ident. Like, is there any other reference of binder ident somewhere?
No, it's just in the parser. So it's like it's like a parse rule.
Over here.
Yeah. It's like this is the parse rule. Like ident is a parse rule, I guess. It just means it can be an ident or a whole.
Great.
But I don't. Yeah, I don't know how then you call it with this QQ thing.
Ident might be something else though. Parser.
Yeah, it's this parser thing. Well, somehow when we pass an ident into the quoting library, it knows how it gets passed.
Yeah, but this is the tactic parser.
Yeah.
Yeah, so
Oh.
this needs to be in a different syntax, I think. See this lean-t syntax, right?
Yeah. So how does
So it's almost
when
like
we call other tactics with it's the wrong thing. Yeah, we need to.
almost like this, right?
Mm.
But that seems like not a thing. It's see GitHub search.
Bind. So can we say colon binder ident?
Yeah, let's see.
What's it complete? Yeah, but we're giving it the whole thing.
Binder. What? Just see maybe there's.
But you see the line above that, it had binder ident as you describe on the line. Yeah. But what does that mean? So maybe you got to say.
Yeah, let's just see if
binder ident of ident.
Yeah, let's just see if there's an easier one here. Just
yeah.
Okay, no. Okay, let's go here. No.
Oh, it's changed. It's changed since it was indexed, I suppose.
Here it is. Here it is. Okay.
Oh yeah.
Okay, so we let the username, right? So this is just going to be a lean ident.
Yes. And then that gives that IDs will be a list of binder idents.
Yeah, but
so maybe we just need to do that. So
this,
binder that.
Is this one line? Is this like a second parameter to make ident?
No, I think it's like the return of the do. So that it's like a do, isn't it? Like do on a list.
You're right. Yes.
Like
yeah.
And so maybe we just do the binder ident. The bit we were missing was the colon ident.
Yeah.
And then how do you do that within a quote?
Yeah.
We shouldn't need the backtick. No. Yeah, I don't know how you do this. Is tilde? Do we splice?
Oh, wait.
Yeah.
Unknown parser binder ident.
Well, that's rubbish. We've seen it.
Inaccessible, maybe.
Maybe
Maybe this one, I think.
Yeah.
Okay, let's. Okay, we're not getting that error.
Okay, that's yes. So maybe we can use that. Still not happy with that.
Let's just make this B name just.
Yeah.
Okay.
What has type blah 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 blah, then the thing that we want,
Yeah.
and it's expected to have the thing that we want. How's what?
Okay, let's just go back here where
Yeah. Binder ident.
okay. This is IDs star.
So I expect that that's like, because it's a list of binder, the IDs is a list, so it's like splicing in a list. But we have one thing, right? But
Oh.
well.
Oh, we want T syntax array, not
Okay.
so this is a single item, and then I mean this is an array. We at least need to be an array. How do we become an array? An array is just a list. Is that really? List to array. Okay. Oh.
Hmm.
Hmm.
Yes, we want to be a syntax array. So how do we?
Array
An
of
array of T syntax.
Okay.
We're So we're in this monads or something.
Yeah.
So we want to bind some. So it's like a map. It's like a map M. And then that B name will have to.
What?
So maybe we do a, instead of let B name equals, we do a bind. So B
Okay.
name back arrow, and then we stuff it in an
yes,
array.
yes.
Yeah. But not like, I don't think, is it like, no, we need to get rid, we put it in the array afterwards, I think.
Yeah.
So we're We put that in an array, in a list, sorry, and then to array. And C names.
Okay, I think it's also possible.
Do you need the let and the bind? I forget. So on line 146, you put how it works. Is a let necessary there?
Yes.
Yeah. Okay. It's just how it. That didn't make sense.
There we go.
All right. We just missed the.
No.
Okay, that wasn't clear from the error message, at least. But, okay.
And then we can.
What were we doing?
Yeah, exactly. Exactly.
We're having too much fun.
Yeah.
Okay.
Oh, so much.
It's not happy.
fun.
Run.
Yeah, almost. There we go. That should do it. Hey. So what were we doing?
What
Right?
did we do?
I mean,
Did we need any of that two-string business? No, we didn't need that in the end, did we? Or did we?
we did. We did.
Oh, okay.
Here. So, okay. So what we did is we created this new hypothesis H.
Mm.
We wanted to rename the previous one. Okay. And to do that, we needed to use rename I. To use rename I, we needed a binder ident. This is how we created a binder ident. So now we had H0, which means what we really want to do was delete it using clear. And now it's gone. So we built a whole replace hypothesis. Or, wow, it's weird outside. Like the light is all yellow. It's just,
Oh.
yeah. But so what we built is apply in.
Yeah.
Right? Because we want to pass our name. We want to provide some theorem to apply. Our name is going to be the last parameter. Then we're going to like try to override our own thing. We're going to succeed. And we need to create a new name for our thing just so that we can delete it. Because
yeah.
If there was clear I, then maybe there is. And we did all this for no reason. Let's see. I don't know, maybe we're back here. Yeah. Okay. Clear. No, not a thing. Okay, great. Okay, let's try it. Let's try to make this a function.
Well, what I have learned is that those, like where we have tactic and binder ident, so those identifiers are actually parser. They're parser functions. Is that right?
This line.
So we got binder ident there.
Yeah.
The thing before the pipe in line 146, that binder ident.
Yeah.
What type of thing is that? Is that that comes from the parser?
Yeah, this is a T syntax.
Oh no, I mean the actual binder ident. 146, yeah, this binder ident, it's a parser description.
Yeah.
So every part of a lean program has one of these parser descriptors.
Yes.
And you can use those in the context in what before a pipe in this quoted thing. So tactic is also a parser descriptor, or
yes. Well,
which I didn't understand that before. I thought this was some special.
No,
but these are all related to the tactics.
This is a parser category again. So that is It's I think a convention to use this syntax. It's not necessary.
Okay.
So even this is part of a parser already.
Mm-hmm.
And then this parser takes a parser description there.
Right.
So you aren't limited to using it like this. This is just the, I think, some convention.
Mm-hmm.
Yeah. So not confusing at all. All right, so let's try to build apply in.
Yeah.
Yes, so apply in takes your hypothesis name, which obviously is a lean identifier now.
Mm-hmm.
And it doesn't need this term syntax anymore. It can now what would this be even? Like, I just want to pass a theorem.
Yeah. So what isn't that still a term though?
Okay, yeah.
But
Yeah. Let's go with that.
T syntax term.
Like this.
Yeah. It's the same type of thing, isn't it?
Okay, let's go with that. Well, it's interesting because now we want to concatenate the name here. Well, okay, wait, not necessarily. Yeah, no, we're fine. Okay. So we're not gonna call make hype because we're gonna do our own thing. Oh, fuck, this is hard. We're gonna get the T out of the monad. So then we just have a term.
Yeah.
Now we're not gonna call fresh. We're gonna call make ident from the name. Okay, call that name tick or ID maybe. It's already an ident. So we don't even have to do that. Okay, we have name. Now we want to run and say the new name is the old name. We have our tactic T, and we also want to use the old name. So we have our theorem and our hypothesis that we want to pass into that theorem.
Mm-hmm.
So now we've done this part. And this can all go away. And we're not going to need to return anything. So this will just be, I think, unit.
Right.
Okay. So at the end, we just return. Even I don't think we need to do that. Okay, now we create a temp name.
Yeah.
And a temp binder.
Yeah.
Then we rename with the temp binder. And then we clear the temp name. Oh, yeah. Well. So what's wrong? Oh no, pause it, pause
Oh, we
it.
need to import a load of garbage at the top. Yeah.
Yeah.
Not a load
Okay,
of
so we
garbage,
still
but
don't know.
some of
which
these are required.
We don't know which one we actually needed. So let's also start to figure that out.
Yeah.
So we'll put this all here. Here. Okay. No?
No, the
Oh.
imports need to come before the opens, I think.
Yeah. Okay.
Yeah.
Okay. And that works. Okay. So now I don't think we need that. Okay, looks good. Looks good. Nice.
Aha.
Oh,
We need the whole of lean, apparently.
yeah.
Opened. Ugh. That must be that symbol must be somewhere in some other namespace, surely.
Yeah, we're gonna figure it out. We're gonna figure it out.
Yeah, yeah.
Cool, cool, cool. Okay, so I think maybe we can say lean.
You say lean dot binder ident. Yes, yes, yes. Yeah.
Yay.
Good.
Okay. Okay, so this. Okay, now let's do apply in here. We wanted to say apply in name. Ooh, did we need toString? Did we? I feel like we definitely still need toString here.
Why do we use it?
Here.
Oh.
Uh,
Oh, right, I see.
Apparently not. Okay, let's see. Let's see what happens.
It's going to
Okay,
get the
apply
wrong
in
name, but we'll see.
this and this can't be working, so I'm just gonna. Okay, Ltac was working. Good. And restart. Yeah.
There we go.
Yeah, that did it. Wow.
Oh, that means we didn't need toString then.
No. Great.
Okay.
Excellent.
Fine.
Wow. That I feel good about that. Like, think we did something. I think that's a good place to leave it as well.
Yeah, I think so.
Cool. Oh yeah. Have a good evening and
Thank you, viewers.
Jimmy McNulty was asking, are you a mathematician? I am not a
Jimmy's no longer here.
mathematician. Oh, he's not here. Yeah. Paul did mathematics. I did not.
Yeah, I did mathematics. Well, you've done plenty of mathematics now, so you can start calling yourself a mathematician.
I don't know. I still feel like I'm proving things about programs and not about mathematics. So I don't know.
Yeah, but programs are programs are proofs.
Yeah, but are they? Yes, they are. But yes. Yeah. I think there's still different types of programs. How's that?
Yeah.
Mathematical, classic, no, can't even say classic. Oh,
You can't say classic.
yeah.
Yeah.
Okay. Anyway, we'll leave that question unanswered. Thank you, anyone who was watching. And I'll stop the stream there. Let's see.